All right. Pascal triangles are a very essential part of combinatorics in mathematics. It's a very easy way of getting a combination of events, and it's also very easy to make. So, it's called a triangle because its resulting formation will look like a triangle. And how to form a Pascal triangle is quite very easy. Every student can do this quite very simply. The very first thing you have to do is to write a 1. And then you go on to write another 1 on both sides. So you can see it's more like a triangle already, but this is just the starting point. This is how you start the triangle. Now, the next thing you have to do is you always start with a 1 and always end with a 1. It's the general rule for making a Pascal triangle. So in this case now, I'm going to start with a 1. And then what I'm going to do next is to add up the two digits. That means this plus this. I'm going to be adding it, and that will be giving me 2. So I have 2 here. And then I will always end up with a 1. So you can see it like that. That's just the way to make this happen. Now I start with 1 again. Now I go on to add the two events. That's 1 plus 2 here. I'll be having 3. And you can see the way we write it. You write the resulting number in between the two numbers that was added. So in this case now, 2 plus 1 again, I'll write the resulting number in between. And then I will also end up with a 1. So you can see how it takes the shape of a triangle. Now you can go on and on and on. I think I would love us to do this to probably 8. So we go on, we have 1 as a starting, then we have 1 plus 3, that will be 4. Then we have 3 plus 3, that will be 6. We have 3 plus 1, that will be 4. Then we have 1 as the ending. So go on again, we have 1, you have 5, you have 10, 6 plus 4, you have 10, you have 5, you have 1. You can pause this video and keep on making your own and make a continuation of this. This is 1, this will be 6, this will be 15, this will be 20, this will be 15, this will be 6, this will be 1. You have 1, 7, 21, 35, 35, 21, 7, 1. All right, let's go on to end at 8. This will be 1, 8, 28, 21 plus this, that will be 56. This will be 70. This will be what? 56. This will be 28. This will be 8. And this will be 1. So this is how we keep on forming our Pascal triangles. And let me now go on to explain to you how and the main reason why we have all this and the main use of our Pascal triangle. Now, I told you already that we use our Pascal triangle for finding a combination of events. So if we want to find a particular number, combination, another number, for instance, let's say 6 combination 2, or we have maybe 5 combination 3. This triangle can be used to resolve all these kind of questions. So let's see how we use this to resolve combinations of events. Now, when you look at your Pascal triangle, you would see that your Pascal triangle starts with 1, and then the next digit here, we have a 2. It starts with 1 here, the next digit was a 3. 1 here, 4. Now, what you need to notice here is that this first one here is for 2 combination R. That means this is for 2 combination. N here is 2 for this particular line. Now, for this other line, in this case, this will be for 3 combination R. And for this next one, we will have 4 combination R. You can see 4 here. For this one, we have 5 combination R, and so on and so forth. All right, so this is the way you identify the column to go to, sorry, the row to go to in order to get your combination. So if you go to the 1, 2, 3, if you go to this particular row, you'll be using it for your 2 combination. Now, how do you then resolve the final answer? For instance, let's say you have 2 combination 0. Well, this is how you use this. The very first one, which is the 1, is for when R was 0. This is for when R was 0. While for the next one, this is for when R is 1. And for the last one, this is for when R equals to 2. So what this means is that if I'm trying to find 2 combination 0, using my Pascal triangle, the result of that will be 1. So you can check that up with a calculator. 2 combination 0 will give you a value of 1. And if you go on to find, so 2 combination 0 equals to 1. 2 combination 1, that's for the second one, equals to 2. And then 2 combination 2 will be equals to 1. So this is the way you use it. Let's keep to a number like 5. So if we're trying to find for 5 combination, of course, the very first one here will be for when R was 0. You start from 0. You start decanting from 0. So when R was 0, this will be for when R is 1, when R is 2, when R is 3, when R is 4, and when R is 5. So that means if I'm told to find 5 combination 2, for instance, well, I'll go on to identify on the Pascal triangle. This was when R was 0. This 5 combination 0, 5 combination 1, 5 combination 2. So my Pascal triangle will obviously tell me that my 5 combination 2 will be equals to 10. So let's randomly find the combination of another event. For instance, say 7 combination 5. So how do I use my Pascal triangle to find this? Well, I go on to the row that identifies with 7 combination, which is this particular row. And then I go on with my counting for R. This was when R was 0. That's 7 combination 0, 7 combination 1, 7 combination 2, 7 combination 3, 7 combination 4, 7 combination 5. So that means my 7 combination 5 will give me a value of 21. So this is how you use Pascal triangle for solving events. All right, there are many more applications of Pascal triangle. Let's look at a few of them. I want you to notice something on the Pascal triangle. Could you notice that whenever we were trying to solve our, let's use 7 combination for instance, did you notice that the value for the value here is the same thing as the value here? And let's try and investigate what were those R, what was R in those cases. If you investigate, you will see this was 7 combination 1, this is 0, this is 1. So that means we had 7 combination 1, it was equals to, this was 7 combination, if you investigate, 7 combination 6. Okay, probably that was a coincidence. Let's go on to investigate some other ones. Let's look at 5, for instance. We can see 10 here, 10 here. Let's see what was going on there. This is 5 combination 0, 1, 2. So 5 combination 2 was equals to 5 combination, this was 3. Oh, probably that was still a coincidence. Let's go on to investigate some other ones. Let's use for 8. 8 combination, this is 2. 8 combination 2 was equals to 8 combination what? 6. That's 0, 1, 2, 3, 4, 5, 6. Was equals to 8 combination 6. Now with this constant observation, I think it's no longer a coincidence. We can make a generalization now and let's see what happens. Could you notice that each time we had our R value, add up to our end value. That means 1 plus 6 now gave us 7. In this case, 2 plus 3 gave us 5. In this case, 2 plus 6 gave us 8. Once we had a situation where adding the two R for the two combinations was giving me the end value, we could notice that they were the same answer. That means they all had the same answer. You can investigate further on any other one. This tells us that we can conclude that if n combination R is equals to n combination K, that means R was equals to K. And there is a lot of use of this particular theorem. Let's see a few of them. A question like this was given, and let me see how you cope with that. We were told that n combination 5 is equals to n combination n combination 2 is equals to n combination 5. And you are told to find n. This is a very important question that you can see in any exam, and you have to understand the Pascal triangle to be able to resolve this. From what I can see here, and from my knowledge of Pascal triangles, I can see that if they told me that n combination 2 was equals to n combination 5, that means 2 plus 5 must be equals to n. And that means my n here is equals to 7. So I found my n to be 7. So these are questions, more like trick questions that you'll be given and you're not expected to spend a lot of time on. Look at this particular question. You were told that 10 combination R plus 2 was equals to 10 combination 6. And you are told to find R. How do you solve for this? Of course, you have to have the knowledge of Pascal triangle. And we know that under Pascal triangle, if we have the same end value, and we are told that the result of each of these combinations are the same, then that means the addition of their base, which we call R in this case. Of course, I know R here doesn't signify the R we had here. So this base, the addition must give you the end value. That means in this case, R plus 2 plus 6, R plus 2 here plus 6 must be equals to 10. You go on to say this is R plus 8 must be equals to 10. R will be equals to 10 minus 8. R will be equals to 2. And that is it. This is how easy it is to solve questions like this once you have a great understanding of combinations using Pascal triangles. All right, let me see how you cope with this particular question I give you. If you were told that x combination 6 is equals to x combination 2, find x. What's your x value? And question number 2, if you were told that if you were told that 8 combination 3 is equals to 8 combination R plus 2, what is R here? Find R. Let me see how you fare with these two questions. 8 combination 3 equals to 8 combination R plus 2, find R. Alright guys, I really hope this was a good time. I hope you had great understanding with the concept of Pascal triangle, and I hope you are able to resolve any question that comes in this line, and I hope you have a good time enjoying mathematics. Alright guys, thank you for joining us. I hope to see you in the next video. Bye bye.